3:47 a.m. Somewhere deep inside Russia, a radar operator rubs his eyes and leans closer to his screen. Tiny dots, 4 of them, are racing straight toward Moscow at over 235 miles per hour. But here's the thing, they look like birds. No heat signatures, barely any radar return, and yet they're flying in perfect formation, closing in on one of the most valuable oil refineries in the Russian Federation. He has seconds to make a decision that could cost his country millions or save it. This is the story of how Ukraine launched one of the most disruptive drone attacks of the 21st century, a mission that defied physics, defeated Russia's most elite air defenses, and ignited a fire that would burn for 3 straight days, cutting Moscow's fuel supply nearly in half. Modern warfare is changing faster than billion-dollar systems can keep up. Welcome to War Mechanics, where we decode the tactics, the tech, and the turning points shaping the future of combat. Because what you're about to see isn't just a strike, it's a warning. Forget everything you thought you knew about military innovation. This isn't the United States developing a next-gen stealth bomber over a decade with a blank check. This is a country fighting for survival, taking hardware built for hobbyists and turning it into weapons that keep generals awake at night. Ukraine's drone program didn't start in polished labs or billion-dollar defense campuses. It started in garages, basements, and workshops, places where ingenuity matters more than budgets. The Beaver UJ-22 and UJ-26 drones were never supposed to fly hundreds of miles deep into hostile territory. Their original missions, recon, light strike, surveillance. But war has a way of forcing evolution. Ukrainian engineers rewired GPS modules designed for farm equipment. They replaced commercial batteries with high-density packs usually reserved for power tools. They strapped on warheads and reshaped carbon fiber frames for stealth. They upgraded software through cheap open-source code and patched vulnerabilities with duct tape and late-night caffeine. This wasn't just engineering, it was rebellion by design. Meanwhile, Russia spent billions building a fortress of layered defenses, S-400 missile complexes, Pantsir point defense systems, electronic warfare networks, fighter patrols, all arranged to stop hypersonic threats, bombers and cruise missiles. And it worked, until the threat arrived in a form no doctrine had prepared for. Tiny drones with radar signatures smaller than a seagull, motors cooler than the roof of a car, flight paths that hug tree lines and coastline curves. Russia built a castle of steel. Ukraine slipped under the door. And the most dangerous part, these drones cost less than a family sedan, while every Russian attempt to stop them costs millions. That's not a battle, that's economic warfare, and it's a war Ukraine is winning. Let's take a moment and look at the bigger question. The real power in modern war isn't about who owns the most expensive weapons, or who uses creative thinking to turn cheap tools into unstoppable threats. I want to hear your answer in the comments. It's 3:47 a.m., the hour when most cities sleep the deepest. Except tonight, something is moving through the sky that shouldn't exist. 4 Ukrainian Beaver drones cruising at around 235 meters, slicing through the dark toward one of Russia's most critical assets, Moscow's largest oil refinery. On a radar screen outside Ryazan, a Russian operator sees a strange cluster. Not aircraft, not missiles. The computer labels them as birds. But birds don't fly in formation, and they don't head straight for a 140,000-ton fuel complex like they have a grudge to settle. At 32 miles out, the lead drone suddenly jumps to 2,600 feet, a taunting maneuver that forces Russia's S-400 battery to wake up. The commander hesitates. Each interceptor missile costs $2 million. The targets may be cheap decoys, maybe nothing. He gets 14 seconds to decide. He takes the shot. Twin missiles blast into the sky, Mach 6 pure confidence. And then, the drones vanish below the radar horizon. The missiles are now chasing ghosts with bad intel. They self-destruct in an empty patch of night air. Millions of dollars gone. 0 results. Russia scrambles the next line of defense Pantsir S-1 systems guarding the refinery. But those radars were built to see fighter jets, not palm-sized threats hugging rooftops. The returns flicker in and out like a bad TV signal. Operators rotate turrets searching for a lock. Too slow. 1 impact, then 2 more. By the 4th strike, the western refinery block erupts into a 200-degree inferno. Pipelines burst. Towers collapse. A firestorm eats through Russia's fuel reserves. It will burn 3 full days before firefighters gain control. Supply lines into Moscow drop by 40% overnight, not because of cruise missiles or stealth jets, but because of 4 drones with modified batteries and homemade software. The refinery was supposed to be untouchable. Tonight, it became proof that the bigger the target, the more humiliating the weakness when it falls. Let's pause here. What scares a nation more, losing fuel, or learning that its most expensive defenses can be tricked by something smaller than a lawnmower engine? While Moscow was still choking on black smoke and panic 470 miles away, Russia believed it finally had the upper hand. At the Novokuybishevsk refinery, 3 Pantsir S-1 batteries stood ready, overlapping coverage, fresh ammunition operators alert and confident. For 11 minutes, they tracked new incoming drones, 12 hostile contacts, slow-moving, predictable, and doomed. At least that's what Russian command thought. But at 4:03 a.m., something happened that threw every operator into crisis mode. 4 of the drones suddenly pulled upward, climbing to 1,600 feet, completely exposed. The radar screens flashed a high-threat classification KH-101 cruise missiles, the same kind Russia uses to strike Kyiv. Engagement protocol is absolute cruise missiles come first. The commanders didn't have time to think, just react. Within 12 seconds, 8 missiles worth nearly $8 million streaked into the night sky. Direct hit, not even close. Because those cruise missiles were a magic trick. The climbing drones had deployed corner reflectors, little folded pieces of metal, designed to bounce radar waves back perfectly. They made a $30,000 drone appear like a 10-square-meter war machine. As the missiles chased the shiny decoys up high, the real Strike Force 8 UJ-22 drones slipped in low from the opposite direction, flying just 165 feet above the ground. Here's the fatal flaw. The Pantsir's radar can digitally scan 45 degrees left or right, but anything behind requires rotating the entire turret, a 4.7-second maneuver. The drones closed the distance in under 3 seconds. Missiles were now useless proximity fuses, don't arm fast enough at close range. The Pantsir spat 30mm cannon fire, but the drones were programmed with random altitude shifts, tiny zigzags that broke the targeting computer's predictions. 1 drone was shredded mid-air. 7 survived. 3 slammed directly into refinery towers, and the last line of defense was reloading. The result: another refinery turned into an industrial volcano. War used to be a test of who had more. Now it's a test of who can think faster. So here's a question for you. Is this the future of warfare, where the smartest trick wins and price tags don't matter anymore? Russia wasn't going to let a third strike play out the same way. At 4:18 a.m. near the city of Voronezh, 6 Ukrainian UJ-26 Beaver drones approached their next high-value target, and suddenly everything went dark. Their GPS dead, their communications cut, their cameras static. Russia had activated the Krasuka-4, one of its most powerful electronic warfare systems, a truck-mounted jammer capable of flooding the airwaves with 500 watts of directed interference across every major military frequency. To understand how overwhelming that is, a GPS satellite signal reaching Earth arrives at 0.0025 watts. The jammer is trillions of times stronger. It's like trying to hear a whisper inside a jet engine. The drones were now blind, deaf, and alone, drifting hundreds of miles deep in Russian territory with no guidance except their onboard gyroscopes. But gyros drift. After 68 minutes of flight, the accumulated error meant they'd missed their target by over 650 feet. A miss meant mission failure, so the drones did what they were built for: survive by shedding load. Navigation lights off. Telemetry off. Secondary sensors offline. Every watt saved lowered processor temperature by a fraction of a degree, because overheating chips mean slower calculations, which mean even more navigation drift. Seconds ticked away. The onboard AI analyzed the refinery visually, not the tanks themselves, but the geometry of their shadows under floodlights, the angles, spacing, alignment. 10 seconds to impact. Chip temperature 208 degrees RAS. Shutdown threshold 212 degrees RAS. 5 seconds. The targeting solution finally locked, but there was no way to share it. Unless the lead drone gambled everything. It fired 1 burst of frequency-hopping spread-spectrum transmission cycling through 1,000 frequencies per second. For 1 microsecond, it found a gap in the jamming power, just long enough to push 128 bytes the target coordinates to the swarm. All 6 drones corrected together like a flock pivoting in midair. Impact. Fireball. Another Russian fuel lake ignited. Electronic warfare was supposed to be Russia's advantage, but tonight Ukraine turned a blackout into a bullseye. By 4:30 a.m., the Ukrainians were testing a different thesis. What happens when you force a fortress to look the wrong way? Primorsko Akhtar Air Base was supposed to be untouchable layered Tor M2 batteries in a Diamond 2 Su-35s, holding orbit at 26,000 feet. Integrated radars sweeping every sector. In training scenarios, this setup chewed up small UAV raids and spat them out. Tonight, it would be taught a new lesson. 8 UJ-22 Beaver drones approached in a coordinated wave, but not like anything the base had rehearsed. Instead of a straight run, every craft executed a sinusoidal weave, random vertical oscillations between about 130 and 260 feet. That's low enough to hide in ground clutter and fast enough to break predictive filters. Tor M2 fire control models assume relatively consistent tracks. Introduce unpredictable process noise and prediction becomes probability, not precision. At T10 seconds, the 4 Tor units lit their rails and sent 16 interceptor missiles streaking skyward. Their seekers were calibrated for quick linear threats: helicopters, missiles, small aircraft. The drones pulled a brutal maneuver, a coordinated 6G vertical climb to nearly 1,000 feet in under 4 seconds. The missile's aerodynamic surfaces stalled. They simply couldn't follow. 1 interceptor detonated on a single target, fragmenting tungsten everywhere. The rest sailed harmlessly above the swarm. While defensive eyes tilted skyward, Ukraine's masterstroke unfolded from the sea. 4 UJ-26s had skirted the horizon at 16 feet above the waves, a line-of-sight hack against ground radars. When the defenders were busy watching fireworks, the seaborne drones slipped in and struck hangars 2 and 3. Inside, dozens of Shahed drones sat fueled and prepped. Massive secondary explosions followed. Within a minute, the runway was shrouded in smoke. Visibility dropped below the 650-foot minimum for Su-35 takeoff. Fighters were grounded. The base that modeled perfect layered defense turned into a smoking tangle of wreckage and grounded jets. Not because Russia lacked systems, but because they were forced into the wrong posture at the wrong time. Reserves were tied up radars, spent crews exhausted. Ukraine didn't win by brute force, it won by choreography. So here's one to think about: if a single well-timed tactic can ground elite fighters and burn your drone fleet on the tarmac, what does that mean for air superiority tomorrow? Oh 4:44 a.m. The point in a mission where most drones would have already crashed, been intercepted, or simply run out of fuel. But 2 modified UJ-26 Beavers were still flying 392 miles inside Russian territory. Behind them, wrecked refineries and a burning airbase marked their trail. Ahead of them, pins a home to a semiconductor plant responsible for producing the guidance chips in Russia's own cruise missiles. This strike wasn't about fuel. It was about brain damage, shutting down the machinery that keeps Russia's precision weapons alive. There was just one problem. An Su-35 was already on their tail. The pilot locked onto the tiny radar signatures and launched 2 R-77 air-to-air missiles, independent hunters using active radar seekers. No ground radar needed, no jamming escape route. These were the kind of weapons designed to swat fighter jets out of the sky. The drones had only agility left. They broke into chaotic barrel rolls, shifting between 500 and 850 feet of altitude. Their goal: push the missile seeker into gimbal lock, rotate too far too fast, and the missile loses its ability to track. The first R-77 detonated behind one of them, shredding control surfaces but leaving the engine somehow alive. The drone wobbled but stayed airborne barely. The second missile scored a kill, turning its target into a cloud of aluminum. One battered drone remained 40 seconds to target. Every second, its onboard computer recalculated survival. It dumped its last reserve of fuel into the combustion stream, one final thrust, to correct a 130-foot drift off target. Closer, closer, closer. Impact. The warhead exploded inside the roof, just 240 pounds of explosive. Not much unless you're inside a high-purity semiconductor facility where even a single particle can ruin millions in hardware. Clean rooms collapsed under dust. $47 million lithography equipment shattered. 6 months of missile-grade processors turned into silicon confetti. The cost of the attack, around $412,000 in drones. The cost to Russia time. The one thing no warfighter can restock. And here's the uncomfortable strategic reality. If Ukraine can hit Penza, what part of Russia is truly out of reach anymore? When the last fireball faded and the smoke finally stopped clawing at the sky, the true scale of the operation came into focus, and it wasn't measured in explosions. It was measured in panic. Within 6 hours, Russia launched the largest emergency air defense redeployment since the start of the war. S-400s moved from frontline positions to cities far from Ukraine. Tor batteries left armored divisions newly exposed. Panzer units that once protected missile brigades were now babysitting oil refineries. For every refinery given protection, somewhere else, a soldier now sleeps under open sky. This is the strategic genius of the campaign. Ukraine didn't just strike targets, it forced Russia to defend everything. But Russia can't defend everything. No nation can. Missile production stalls because the Penza chip facility is offline for at least 6 months, and that's the optimistic estimate. Fuel distribution is rationed not just for civilians, but for the military itself. Jets fly fewer sorties. Armored units postpone rotations. Logistics trucks wait in line for diesel that isn't there. And perhaps the most damaging blow of all, the psychological shift. Russian commanders now have to assume that any location, no matter how deep, no matter how well guarded, might be hit tonight. There's no sleeping far behind the lines. No safety in distance. Meanwhile, Ukraine unlocked a terrifying equation. Cheap plus smart, expensive plus predictable. It's not just missiles versus drones anymore. It's economics versus ego, adaptation versus legacy. One side evolves weekly, the other is still defending yesterday. If a few modified drones can force a nuclear superpower to rewrite its entire national defense in a single night, what happens the next time Ukraine multiplies this by 10? What we just witnessed wasn't a single mission or even a series of daring attacks. It was a paradigm shift. A nation fighting for survival has shown the world that future power won't belong to whoever buys the biggest weapons, but to whoever adapts the fastest. For decades, warfare has been built around giant budgets, massive platforms, and the belief that advanced systems like the S-400 or Su-35 could shut down anything smaller than themselves. Ukraine just proved that belief dangerously outdated. A few drones costing less than a family SUV turned entire refineries into fire pits. A fleet of unmanned aircraft no larger than a dinner table erased an air base meant to protect the Russian heartland. A modified drone, limping damaged, barely flying, took out a semiconductor hub worth tens of millions and rewrote Russia's production timeline. Those aren't just tactical wins, they are strategic earthquakes. Because if the most defended facilities in Russia can fall, what about anywhere else in the world? The Pentagon, the PLA, NATO, every major power is watching this play out in real time. And they're asking the same uncomfortable question. What happens when the cheap and clever defeats the costly and confident again and again? This war is revealing something profound. Innovation doesn't trickle down anymore. It rushes upward from the battlefield designed by soldiers, built in workshops, coded on laptops refined in the middle of the night under missile fire. Ukraine isn't just fighting for its land. It's defining what military relevance will look like in 2030, 2040, and beyond. And whether we like it or not, every nation will have to adapt to a world where a $400,000 drone swarm can cripple a billion-dollar defense grid. So here's where I pass the baton to you. Comment below with what you think this means for global security. Because the next chapter of warfare isn't being written in think tanks, it's being argued, tested, and discovered right here, right now, in the age of the drone. This conflict is evolving faster than any military analyst ever predicted. What seemed impossible 2 years ago is now happening. Weekly drones diving under radars, refineries erupting into firestorms, air bases falling to aircraft no bigger than a suitcase. We are watching the future of warfare being engineered in real time, and every strike writes a new rule in the playbook. Here on War Mechanics, we break down the tech, the tactics, and the transformation reshaping global power. If you want to understand what tomorrow's battles will really look like and why billion-dollar defenses are losing to backyard innovation, you're in the right place. Don't fall behind while the battlefield changes. Hit subscribe, drop a like if this gave you a new perspective, and share this analysis with someone who still thinks drones are just toys. Stay sharp, stay curious, and stay ahead of the war that's already begun.